Guys, so I hope you have understood the section or the problems we have dealt with during the live class. So this is actually the continuation of the live class itself. So we were dealing with the numerical problems of the chapter system and particles. Okay, so here I'm starting in this video, I'm starting with the section rolling motion, right? So from rolling motion we go from backward to forward. So forward type questions are the first initial section questions I would have answered during the live class, right? So before moving to the rolling motion section, there are some of the questions section. I want to give you small tricks while solving it. Suppose the question is like this, guys. You are given a scenario that a ring is there, a disc and sphere, right? And these three guys are having same mass, and obviously they are also having radius same, and they are rolling down an inclined plane like this, right? So you are that is ring, disc and sphere. The three guys, if they are having same mass and radius, and they are rolling from the top position of an inclined plane to the downward plane. Let's say the plane is having the height h, the inclined surface is having the length L, and theta is the angle, right? So they are asked which of these three guys will reach the bottom earlier, which will be reaching earlier and which will be reaching last, right? So if such a question comes up, so it is mandatory that you remember the acceleration, that is rotating acceleration, right? Acceleration of a rolling body on reaching the bottom of an inclined plane. You remember that equation, right? This AR is equal to G sine theta. Sorry, and again I will make it silent. Okay, G sine theta divided by 1 plus K squared by R squared. This is what I have taught. There is an equation like this. If someone asks you how this equation came up, that also I can say. Let's take a few seconds of your time, guys. So let's suppose this is an object which is rolling downwards, right? Let's say it is having a friction in opposite direction, right? Let's say the angle is theta. Now this acceleration, if you have, this is g, right? So g, this angle is theta, means this angle is also theta, so this becomes g cos theta, and this will be g sin theta. We have learned it earlier, right? Now this much clear, right? So this force is acting on an object, right, which is rolling about its axis, right? It is rolling, right, without sliding. So this perpendicular distance is now radius of that object, right? So force into this perpendicular distance is, this is friction, that is force into perpendicular distance, that becomes the what? Our torque. So torque is equal to F into R, right? Now torque is also equal to I alpha, right? That also you know. So can't I write force is equal to, that is frictional force is equal to I alpha by R? Yes, I can write. Keep that. Right. Now here in this scenario, right, by Newton's second law, I can write that, remember we have included here m, and m you can write. So mg sine, and the object is moving downwards, so the acceleration will be downwards, right? So I can write by Newton's second law, mg sine theta minus frictional force is equal to ma, right? Now here the frictional force F I am going to replace with I alpha by R, right? Now what is the relationship between A and alpha? That is, A is linear acceleration, alpha is rotatory acceleration, that is equal to A is equal to R alpha. So here in this equation I am going to replace alpha with A by R, right? Here I can write alpha is equal to A by R. Let us replace here. So it will be mg sine theta, right, minus IA by R square, right, is equal to MA. Let us bring A, guys, in the one side. So A M, right, plus I by R squared. This is equal to mg sine theta. Or I can write A is equal to mg sine theta divided by m plus I by R squared. Yes, yes. Now I can be, now this equation you can, if you want, you can keep it like this itself, or see mg sine theta divided by m, and moment of inertia in terms of radius of gyration I can write mk square divided by r square, right? Clear? From here I can take m outside common and numerator also has m, so the answer becomes g sine theta divided by 1 plus k squared by r squared. This is the expression for the rotating acceleration or rolling acceleration, acceleration of a rolling body, right, on reaching the bottom of an inclined plane. This is the expression I told you can actually generate. Now you can generate. I hope you understood. Now see guys, now this is not the answer we are seeking. What we want to know is what the time period is, right? So this is the acceleration by which the rolling body has reached the bottom of the surface. Now, if that rolling body is undergoing a displacement of s, see, the body is moving by itself from here to here, right? So the initial velocity is 0. So you know s is equal to ut plus half at square. So here u becomes 0. So I will remove this term. So it becomes half at square. Right. From here I can say that t, this is constant. If I consider this is constant, half is constant. So I can easily say that time is inversely proportional to root a, right? A and t square. So this is very important scenario. That means if a rolling body is having higher acceleration, then it will be having less time to reach the ground. If a rolling body is having lower acceleration, it will take maximum time to reach the ground. Keep this in mind. The object which is having higher acceleration takes less time to reach the ground. A body which is having less acceleration takes more time to reach the ground. This much is clear, right? Now I am going to make sure that you understand how can I say whether A is greater than or less. See, any parameter, look here, right? Any parameter, let's say this k squared by r squared. This g is constant, sine theta is constant, 1 is constant for any inclined plane, right? The g is constant. And same inclined plane if we are considering, then the factor which is changing for any body, whether it is disk or sphere, etc., it is k squared by r squared, right? So I can say the value, if the k squared by r squared value increases, when k squared by r squared value increases, then I can say that means A will be what? See, I will tell you like this. Okay, sorry. Now, k squared by r squared value, when it increases, the AR will decrease, right? When the denominator part when increases, AR decreases, that means time increase, right? So I can just, if someone asks you which will be reaching the ground later, or which will be taking more time, then I can just select that object which is having k squared by r squared value higher. Because when k squared by r squared value higher, that means acceleration reduces, that means more time to reach ground. This much clear? Now the problem comes, how can I find the value of k squared by r squared? See, make a column, body, k squared by r squared. And if you want, you can write for AR also column, right? So let us, this is better if you can mug up, right? So first let us deal with a ring. That is, ring is rotating about its axis like this, right? That's rotating like this, okay? So if you asked what is k squared by r squared, it's very easy. How can I calculate k squared r squared? See, for the key ring, k, or how can I find it, right? You know, moment of inertia of ring about its axis of rotation is mr squared, and you can write in the term of radius of gyration as mk squared. So what will be I by I? It will be 1, right? So mr squared by k squared is equal to 1, or I can say k squared by r squared in the case of ring is 1. I hope you understood. See guys, k squared, that is the radius of gyration of a ring, right? So mr squared is its radius, in moment of inertia, equated with what? Mk squared. That means k squared value is equal to r squared, so k squared by r squared will be equal to 1, right? Put that value in the case of A, which is what? G sine theta divided by 1 plus k squared by r squared, right? So k squared by r squared is 1, 1 plus 1 is 2. So I can write AR is equal to g sine theta by 2. This much clear? Right. Similarly, you can look for ring also. Ring, not ring, disc, right? Disc as well as cylinder. Why? Both of them are having moment of inertia as mr squared by 2, right? So equate mk squared equivalent to mr squared by 2. So that means k squared is equivalent to r squared by 2, or I can say k squared by r squared is equal to 1 by 2, right? So this will be having k squared by r squared value is 1 by 2. If you put the value in AR, you will get 2g sine theta by 3. Similarly, go for solid sphere. It will be having k squared by r squared as 2 by 5, and AR will be equal to, or I can just rub this one because I have already written in the heading as AR. So AR's value will be 5g sine theta by 3, right? Whereas hollow sphere is having 2 by 3 so it will be having k squared by r squared as 2 by 3, so 3g sine theta by 3, oh sorry 5, sorry 5, right? So this and all are the values of correspondingly for a body. It's a squared by r squared. Now look here guys, now out of this ring, disc and sphere, that was our question, right? These three guys which is having maximum acceleration, this guy or this guy or this guy, see g by 2, that is 0.5, g by 2 by 3 means around 0.6, 5 by 3 means it is 5 by 3 sorry, I'm so sorry guys, there is a 5 by 7, please correct it, it is 5 by 7, just substitute the value, you will get 5 by 7 is around 0.7. So guys, that means this solid sphere is having maximum acceleration, right? Maximum acceleration means it requires less time, so solid sphere will be reaching first, then disc will reach, then last only the ring reaches the ground. Clear? So which will be I hope you understood, right? The acceleration of the sphere is maximum, so that ring will be having least time period, right? So the sphere will be reaching the ground earliest, and whereas the ring will be reaching last. Clear? So this is a very important section, not there in your textbook again. This and all are neat topics guys, but it is better if you understand. Clear? Right, so moving on to the problem section, right? The first problem which you can see is the one which I dealt just now, right? A disc and a sphere of same radius but different masses roll off on two inclined planes of same altitude and length. Which one of the two objects gets to the bottom of the plane first? And similarly, there is another question like this. 77th question is also same, so I covered two questions with that entire topic which we dealt till now. Right, so let us move on to the next question. 73. The ratio of acceleration of solid sphere rolling down an inclined plane of angle theta without slipping and slipping down the incline without rolling. I hope you didn't understand. You're asked the ratio, right, of the same. That is, a solid sphere is going to roll down, right? Once, and you're asked the ratio in such a way that in first case it is rolling down without slipping, which formula you know, and the second case is it is slipping. So let us understand the scenario. You are asked if A1 is the acceleration of the solid sphere without slipping on an inclined plane, then A2 is the acceleration of the same sphere if it is rolling down but with the slipping. I hope you understand what slipping is, right? This is an object, right? If it is dragging on the surface, then that means it is slipping. If it is just rolling, right, that is means rolling without slipping. Clear? Right? So what is the formula for equation for acceleration of any rolling body on an inclined plane without slipping? It is g sine theta divided by 1 plus k squared by r squared. Now my question is, what will be acceleration of a body which is rolling down with the slipping? right? So that is something which you have just now learned, right? This is an object, or you have learned earlier also. So this will be g, and this will be g sine theta, right? When theta is this angle, and this will be g cos theta. G cos theta will be can cancel out with the normal reaction, obviously, with m, right? So g sine theta is the acceleration, right, of the sphere which is slipping, right? So a2 is equal to g sine theta, because normal acceleration, you are asked the equation of acceleration when the object is just normally moving, you are not understanding any scenario for it. So a2 is equal to g sine theta. You are asked what is a1 by a2 now. So you can understand by the relationship a1 by a2. If you go off, then the g sine theta can cancel out, right? So a1 by a2 will be equal to 1 plus 1 divided by now. Yeah, 1 divided by, sorry, 1 divided by 1 plus k squared by r squared. Now the problem comes, what is k squared by r squared? So you can utilize the sheet which I have just wrote down, right? What is k squared by r squared in the case of solid sphere? It is 2 by 5, right? So just substitute this. So I hope you understood the meaning why I took it, right? So 1 divided by 1 plus 2 by 5. So you will get 5 by 7 as the ratio of acceleration of the sphere rolling down when it is without slipping is to with slipping. Clear? I hope you understood. Now let us move on to the next question, guys. Oh, which one? Okay, let us look at the 74th question. A small object of uniform density rolls up a curved surface with an initial velocity v. It reaches up to a maximum height of 3v squared by 4g with respect to the initial position the object is. How will we solve this question, guys? I hope you understood question. If not, please listen to what I'm telling. Okay, so you are given a scenario like this, right? That is, an object is rolling like this, right? A small object of uniform density rolls up, right? So it is moving up, right? This is an object, right? It is rolling up with velocity v. It reaches up to a maximum height of 3v squared by 4g with respect to the initial position. Curved surface, so this question is correct. So it reaches maximum height like this, let's say this one. So the maximum height is 3v squared by 4g. It has moved from here to here. This much clear? Right. So you're asked what object it might be. So you know this object is going to rotate about its axis of rotation, this about its center, right? So if I know the moment of inertia of this object, can't I state which object it is? That is, if moment of inertia comes about 2 by 5 mr square, right? So I can say this is a solid sphere. If it is 2 by 3 mr square, I can say it is hollow sphere, like that, right? So as if it is 1 by 2, I can say it is disk, or I can say it is ring, cylinder, right? So this much is clear, right? So I have to find the moment of inertia of this object. So we are supposed to use law of conservation of energy, right? So here the entire energy will be potential energy, but since the object is rolling up, so it is having both kinetic energy and rotational energy. Kinetic energy as in translational energy, and it is having rotational kinetic energy. So full rotational kinetic energy is half I omega squared plus, this is rotational, plus half mv squared, this is translational, is equal to mgh. Mg, and what is h? It is 3v squared by 4g, right? So I can remove 1 by 2 section, or can write half I omega squared is equal to 3 by 4 mv squared, right, minus because this gg cancels off, right? So 3 by 4 mv squared minus half mv squared, right? So let us make this as 2 and this becomes 4. So 3 minus 2, 1 by 4 mv square, right? So mv square by 4, right? So here in LHS you are having half I omega square, right? Right. So omega I can write it as v square v by r, right? I hope you remember omega is equal to v by r, right? So here I can write it as half I v by r whole square, or I can write v square by r squared is equal to mv squared by 4. So you can cancel v square, and you can cancel this 2 with this 4, so this becomes 2. Or I can say I is equal to m r squared by 2, right? So you got the moment of inertia as mr squared by 2. That means the object can be either a disk or it can be a cylinder. Clear? So in this section there is no cylinder mentioned, only disk is mentioned, so you can say it as disk. Clear? I hope this much is clear. Right, now let's move on to the next question. Let me rub this section, guys. Okay, so a drum of radius r and mass m rolls down without slipping along an inclined plane. The frictional force. So you are given 4 options, right? What happens to the frictional force, right? That is, it is very easy if you understand the scenario, guys. See, I hope you, a drum is there, right? So it is having a radius r and m and this is rolling down without slipping. That means there is no frictional force, right? So work done by the frictional force when the drum rolls down is 0, right? So there is no net work, right? The W net is equal to 0, right? And what is net work here? It is actually work due to translational motion plus work done by rotational motion. That is equal to 0. And what is the relationship between work and kinetic energy? Change in kinetic energy. It is change, work is equal to plus change in kinetic energy. Work energy theorem. So I can write work of translation motion as change in kinetic energy in translation motion plus change in kinetic energy in rotational motion, which is equal to 0, right? That means I can write kinetic energy, right, translational is equal to change in kinetic energy in rotational. That is, all the kinetic energy change in the translational is converted to rotational, and either way, right, in vice versa process, right? So the conservation of energy is happening in such a way that translation energy converts to rotational energy, or rotational energy converts to translation energy, right? So the frictional force, what it is saying, it is what is decreasing, negative is rotational, right? So decrease in rotational and translational motion. So the net work which is done by the friction becomes 0. There is no friction, means no work done by the frictional force. That means there is only conversion of energy between rotational and kinetic energy. Clear? This much is clear. It is very easy to understand the logic of the question. So let's move on to the next one. That one, okay, let's reach by dragging. So you are having a question like this: a solid cylinder of mass m and radius r rolls down on an inclined plane of h without slipping. The speed of the center of mass when it reaches the bottom. It's very easy, guys. You have a equation for a rolling, right, velocity of the rolling body on reaching the bottom, right? So cm as well as vr will be same, right? So vcm or vr, I can write it as equal to root 2 gh divided by 1 plus k squared by r squared. I hope you have remembered the equation from the previous video. Now you can go for the lengthier calculation, or you can just write which is k squared by r squared. For the case of this is a solid cylinder, right? In the case of solid cylinder, it is 1 by 2, right? K squared by r squared, you can just substitute the value 2gh divided by 1 plus k squared by r squared. I am writing it as 2 by 3. Sorry, a cylinder, na? So it is 1 by 2, right? So 2 plus 1, that is 3 by 2, or you can write 4 by 3 gh. right? So you straight away get this answer. Clear? So this is the profit of learning k squared by r squared value. It helps a lot, guys. That's why, right? So moving on to the next question. So 77th question is dealt with earlier itself. Now we'll go with the spherical ball rolls on a table without slipping, then the fraction of its total energy associated with the rotation. The question is just very simple, guys. You are asked how much of the total energy is made into rotational energy. That is your question. A spherical ball is rolling on the table without slipping, then the fraction of its total energy associated with rotation. So you are asked what is rotational kinetic energy is to total energy. So what is the equation for rotational kinetic energy? It is half I omega square, whereas the total energy will be sum of rotational as well as kinetic energy. So it is half I omega square plus half mv square. Simple, right? So in place of I can write it as mk square. For any object, the radius of gyration can be written, right? So mk squared omega squared divided by half mk squared omega squared plus half mv squared, right? Now in the entire term there is m, so I will remove m from here. This is k now, right? And every term is having half. I will remove half from here, right? Oh, right. This I will bring v squared here. You can write v is v is equal to r omega, right? So it is k squared omega squared divided by k squared omega squared plus r squared omega squared. Now omega squared common, so I can remove that one, right? So you will get a function of ratio of rotational kinetic energy by total energy as k squared divided by k squared plus r squared. Now what is k squared in the case of this material? That is, what is the material here? It's a spherical ball, now, right? So either you guys can go by this method, or I will tell you to take k squared as common, so it will be r squared by k squared like this. Can I write it? Right? So take k squared as common, so k squared cancels off. So 1 divided by 1 plus r squared by k squared. Now what is k squared by r squared in the case of it is 5 by 2, no? 2 by 5, sorry. So write it as this one, k squared by r squared if it is 2 by 5. So r squared by k squared will be 5 by 2. So I can write 1 divided by 1 plus 5 by 2. So it will be 2 by 7. Right? You got the answer. Clear? So this lengthier process, because I am writing, you guys can actually do it in your without using paper, so you can do the calculations, not that tough. Right, let's remove this guy. Let us move on to the next question, that is this one. Okay, 50th question. As you can see, I am going from back to forward. So next topic which we actually learned about here is moment of inertia, right? Rotational kinetic energy and power, right? So let's read the 50th question. What has been asked? Two disks of same moment of inertia rotating about their regular axis, passing through the center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are both brought into contact face to face, coinciding the axis of rotation, the expression for loss of energy during the process. It's a very simple concept question, guys. See, they are having two objects, right? Let's say this two objects, right? And they are rotating, let's say with same different angular velocity, right? This is velocity omega 1, the other is having omega 2. Both are having moment of inertia same. So obviously I'm going to take both as I. Now it is said that if this is happening like this and both are moving in this rotatory motion, it is said that if this one is brought like this, right, they are face to face and their axis of rotation has coincided, right? If you are told, I hope you understood what happened, you are brought like this, okay, if this is brought like this, so what will be the loss in kinetic energy, right? So initially there was some kinetic energy which was different for these two guys. If this any one of them is brought in such a way that their axis of rotation is coinciding and they are facing each other, then what would be the loss in kinetic energy? I hope you understood the question. Right, so how would you do this one? This entire process is based upon conservation of momentum, right? Because in this entire process you are not doing, or any external force has not been mentioned, right? So I would say that the torque is zero, right? There is no force means torque is zero. So torque is zero means there is no what? Change in momentum, that dl by dt is equal to 0, or I can say L is constant, right? L constant means, what is L's equation? It is I omega. So I1 omega 1, that is for this one, right? So I1 omega 1, right, plus I2 omega 2, that is for this guy. Their total momentum, or angular momentum, right, is equal to, let's say when they combine each other, right, new angular velocity, let's say it is omega, right, and the new moment of inertia will be sum of these two guys, that is I plus I, that is 2I, right? The moment of inertia of each one you can add, right? I1 plus I2, so it is both of them are equal, so you will take it as 2I, right? From here you are told that all those guys are having same moment of inertia, so this I goes off, this I goes off, right? So I can cancel these two guys. So can't I write omega is equal to omega 1 plus omega 2 divided by 2? That is the net angular velocity of this entity is equal to average of the angular velocity of these two objects separately, right? Now this is not the question. So you are asked what is change in kinetic energy, or you are asked what is loss in kinetic energy, means you are asked what is final kinetic energy minus initial kinetic energy, right? So what do you say about kinetic energy initial? That is half I omega 1 square, that is the kinetic energy of the first object, plus half I omega 2 square, that is the kinetic energy of the second guy, right? Now what will be the kinetic energy final? It will be half moment of inertia of the entire entity into omega square, velocity of the entire entity, right? Now here I can cancel 2, right? So I'll get omega. What is omega? That is omega 1 plus omega 2 into 2 whole square, right? So omega 1 plus omega 2 by 2 whole square. So I have got final kinetic energy and initial kinetic energy. You are asked what is loss in kinetic energy, that is kinetic energy final minus kinetic energy initial. Please do the calculation, guys. You will get the answer as 1 by 4 I omega 1 minus omega 2 whole square. Calculation, please do it by yourself. Okay, now the next question we want to move off. Okay, let me remove this section. Okay. And read the next question, very important question, which is present as the second one, or the second question. I rubbed it off. Okay, this one. From a disk of radius r and mass m, a circular hole of diameter r whose rim passes through the center is cut. Right, what is the moment of inertia of the remaining part of the disk about perpendicular axis passing through the center? That is, it is same as that of the finding the center of mass of a disk from where another small section is removed, right? So important section, because the concept is very important to understand. Let's say this is a disk, it is having center, or let's say this is its radius, right? They said that another hole is drilled from inside it, so that the hole's one end is connecting, or rim is connecting to the center of the disk. This much clear? You are asked what is the moment of inertia of this much portion, right? Clear? So you know that the moment of inertia of a remaining portion, that is this one, is equal to moment of inertia of total portion minus moment of inertia of the removed portion. This much clear, right? So you first have to find the moment of inertia of the total disk, and you have to just minus the moment of inertia of the removed disk or removed section. Now what is the moment of inertia that is total disk, that is if this entire entity was present, what would be? That is very easy. What is the moment of inertia of a disk about the axis of rotation is passing through the center, right? It is mr squared by 2. So just write it as mr squared by 2. That part becomes easier. Now the problem comes, what is the moment of inertia of this section? Right, so if you want to find the moment of inertia of this much section, that is this hole, so you have to know the mass of this disk, right? That is this much disk is removed, right? This much part is removed. So removed disk mass you have to know, right? So let us say that capital M is the mass of this entire disk, from where the portion is not removed, right? Clear? So that means, let's say sigma, that is mass per unit area, right? That is 1 meter squared area will be having this much mass, right? So 2 meters squared will be having 2 into m by a, or I can write it as 2 sigma mass will be there, right? So similarly, see, A is, let us say A is the area of the entire full disk. That the entire full disk, the A was the area, it had mass m, right? 1 unit had mass m by A, right? Right, you can even think by this method also, no problem, right? Let us say there is a small area, I'm going to consider A dash. Then what would be the mass of that much area? 1 unit has m by area, means A dash unit will be having m by A into A dash mass. See, A area has m mass, 1 area has m by A mass, then A dash new area will be having m by A into A dash mass. Right, now this A dash is the area of the removed disk and A is the area of the full disk, right? Clear? So A dash, that is the area or the disk removed, right? Disk removed, right, has mass equal to total mass by total area of the entire disk is this much, into what would be the A dash, that is the area of this small disk. Its radius will be r by 2. From here to here it is r by 2, right? So A dash can be written as by r by 2 whole square, right? Now by calculation you can find that m by 4 is a mass of this removed disk, right? So you got the mass of the removed disk, right? Now the moment of inertia of the removed disk has to be found, right? About this point, right? So this point's moment of inertia you are supposed to find, right? About this one, that is, again I'm repeating, moment of inertia of the removed disk about this point of axis. Clear? Right? So that will be what? Its mass, right? This section, right? Its mass into what is its rate? This, if I consider this as a separate entity, this one, right? So I want to find the moment of inertia as a tangent, right? And this moment of inertia I know, right? This I want to find I dash, right? So I dash is equal to I plus m r squared, or this distance is what? Actually r by 2, because from here to here it is r, so then this radius is r by 2, so m by r by 2 square. Now the problem is that this removed disk is not having m mass, it is having m by 4 mass, right? Clear? Now what is I then? This is also disk itself, right? So its moment of inertia about its center is what? M into, right, m into what? r by 2 by 2 whole square. Why? Repeating it again, guys. Moment of inertia unknown. This one is equal to known moment of inertia plus mass of this disk into the distance between these two parallel axes, which is r by 2 whole square. This much clear? Right. Now what is I? That is the moment of inertia of this removed disk. That is m dash. That's a mass. I will replace it with m by 4. It's okay. Into, right, its radius, right, any disk is having moment of inertia is equal to m r square by 2, where r is the radius of the disk. What is the radius of the disk here? It is r by 2, then divided by 2, right? Clear? And what is the new mass of this disk? It is m by 4, so replace m dash by m by 4, right, plus m by 4 into r by 2 whole square. Right, so now find the value of I dash, right? You will find it as 3 by 32 mr square. Calculation, please do it by yourself. So now you got the moment of inertia of this disk, right, which is removed, right, and you have already found the total moment of inertia, which is what, m r square by 2. So m r square by 2 minus 3 by 32 mr squared. So you will get the answer as 13 by 32 mr squared. Right, so this is a calculation based question. Just understand the logic of it, don't mug up, guys. So first point was to find the mass of the removed disk, right, and then finding the moment of inertia about the point where you are asked. You are asked what is the moment of inertia about the axis, all earlier axis of rotation itself. So this itself, right, so you have to find the moment of inertia of the total disk about this axis. Similarly, moment of inertia of the removed disk about this axis. So the removed portion, if I have removed like this, right, so its moment of inertia through its center, I know. You are asked what is the moment of inertia as a tangent. So these two are parallel. So applying parallel axis theorem, unknown moment of inertia I dash is equal to known moment of inertia plus m into r square, or the distance between these two guys, which is r by 2 whole square. Now m dash into r by 2 whole square. Now I, that is the moment of inertia of the removed disk, is mass of the removed disk into radius by 2 square. Right? Clear? You just substitute the value. Clear? Now let us move on to the next question, guys. Can I remove this thing wholly? Okay. Let us move on to the 52nd question. 3 identical spherical shells, each of mass m and radius r, are placed as shown in the figure. Consider xx dash, which is touching the 2 shells and passing through the diameter of the 3rd shell. Moment of inertia of the system consisting of these 3 spherical shells about xx dash. Right. So you are given 3 shells here. Right. You are asked what is the moment of inertia of the total system. This much clear? Right. Now let us name these shells, guys. Okay. Let us name this shell as 1, and this is 2, and this is 3. Alright. Now moment of inertia of shell 1. Right. It is along the diameter, that this axis is passing through it as a diameter. Right. So moment of inertia of the first shell, if I say, is moment of inertia about diameter. For a diameter section, it is 2 by 3 mr squared, guys. Please look into your book, in your textbook. You are already given the moment of inertia of a sphere or a shell. Shell means hollow sphere, right? I hope you know shell and hollow sphere are same, right? So it is 2 by 3 mr squared, so that is very easy. Now comes the second hero, that is moment of inertia of this guy. For him, this axis is passing as a tangent, right? So for him, you have to find the value. Suppose this is a shell, right? The axis is rotation is like this. So you know this shell too, okay? The moment of inertia, this is I, and this is something you want to find, right? So I dash is equal to, what is here? The radius is r, So I dash is equal to known moment of inertia. This is along diameter, right? So it is 2 by 3 mr squared plus m into r squared. So you will get 5 by 3 mr squared. This is the moment of inertia of the second sphere. Or sorry, not second sphere, the second shell. Alright? Here this is for first shell, this is for second shell. Now so obviously the third shell is also having the axis of rotation as its tangent, so I need not calculate it again, right? So it will be 5 by 3 mr squared itself. So third shell will be also having moment of inertia 5 by 3 mr squared, right? Now total moment of inertia will be sum of these three guys. So you just have to add, you will get 4 mr squared as answer. Clear? Right? Now let us remove this guy now. Okay. Now 53rd. The radii of gyration of circular ring and a circular disc of same mass and radius about an axis through its center and perpendicular. We are asked what is k1 by k2 or radius of gyration of what and what? Of circular ring and disc. Right? So this section, if I talk about ring, right, momentation area of ring, it is mr square, right? Whereas moment of inertia of a disk is mr squared by 2, right? Clear? Now any moment of inertia, let us say in the case of ring, I can write it as mk square. Here I am going to write it as k1 square. Similarly for disk also I can write it as mk2 square, right? So let us equate these two guys. So k1 squared is equal to r squared and k2 squared is equal to r squared by 2. Equated guys, right? So k1 squared by k2 squared is equal to, you will get it as 2 by 1, right? Or I can write k1 by k2 is equal to root 2 by 1. Simple as it is. Just compare the equation, right, of with the radius of gyration. It is very easy. Clear? So moving on with the next question. Let us move on with the 54th question. Moment of inertia of a uniform circular disc is maximum about an axis perpendicular to and passing. Oh, you're asked for where the moment of inertia is maximum. See, you know, suppose I know the moment of inertia for center. So as much the distance goes on, that much increase in moment of inertia, right? mr square. So obviously point B is farther from the axis of rotation, right? So this point B will be having the maximum what moment of inertia, right? Clear? Let me remove this. Okay, let us do the 55th question. I hope this is visible. Moment of inertia of thin uniform rod of mass m and length about an axis passing through its midpoint and perpendicular is given as I naught. This is given as I naught. Its moment of inertia about an axis passing through one of its end and perpendicular to its length. This is very easy. You are asked what is the I. So L is the entire length, means this will be L by 2, right? So I, that is unknown moment of inertia, is equal to known moment of inertia plus mass m into distance between these two axes, that is a parallel axis theorem, right? That is L by 2 whole square, right? You will get I naught plus ml squared by 4, right? Clear? Very easy question. Need not have that much difficulty while solving the problem. Right? Let us do the 56th question. That is a pen mark which I would like to remove. Okay. 56. A small mass attached to a string rotates. Okay, rotates on a frictionless table as shown, If the tension in the string is increased by pulling the string, causing the radius of the circular motion to increase by a factor of 2, the kinetic energy of the mass. So, okay, I'm repeating again. A small mass is there, right? It is rotating on the in this way. There is no friction. The tension is increased by pulling the string, right? And the radius of the circular motion, now it becomes double, right? You are asked what is the kinetic energy. Now there is an equation, guys, remember, in relation with kinetic energy and linear momentum, which is p squared by 2m. That is the relationship between kinetic energy and momentum, right? Now similar equation can be also written for what? Rotational motion also, that is kinetic energy. In place of p it will be L squared 2, and in place of m I will write I. So write this expression also, this kinetic energy is equal to L squared by 2I, where L is the angular momentum and I is the moment of inertia. Now since there is no friction, so obviously due to conservation of angular momentum, L is constant, right? So L remain conserved about the center. So L is constant means I is equal to mr squared, right? So and we just wrote kinetic energy is equal to L squared by 2I. In place of 2I I am going to write it as mr squared. All right, this is for the first case. Now in the second case, the kinetic energy, now the radius has doubled, right? Or I can say it is increased now, radius circular motion decrease, sorry, it is decreased by factor 2, means the new radius is half of it. Okay, so kinetic energy now, second, this is first case, this is second case, is L squared by 2m, and the radius is half, means it is r by 2 whole square, right? So it will be L squared by 2m r squared by 4, right? Now how much value the kinetic energy is changed? It is 4 times the initial kinetic energy, right? So final kinetic energy is 4 times the initial kinetic energy. So I just wanted to introduce that equation, that's why I took it. It's very easy to solve. Alright, so I hope you understood the equation, guys. It is not there in your textbook, I'm just introduced it. Clear? Now let us move on to this one. This one we did in the live class, so leave it. So 58, a thin rod of length L and mass m is bent at this point into two equal halves so that the angle between them is 90 degree. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by the two halves of the rod is, that is, you are having two rods like this, right? The thin rod is bent actually, so it is just like two rods now, right? Let's say this is L by 2 and this is also L by 2, even if it doesn't look like that, right? And you are asked if the axis of rotation is like this, right? You are asked what is the total moment of inertia. So obviously it will be the sum of the moment of inertia of this guy and this guy, right? Clear? So it is very easy, guys. This axis, even if you see, this is x, sorry, this is y, this is x, and this is z. So what is the speciality of x, y, z? They are all perpendicular to each other. So y is perpendicular to z, x is perpendicular to z. So if I consider each entity as separate, that is this guy, and let us say x, right? X is having this axis, right, passing through this one, right? So I hope you remember the tangent equation. If not, please by heart. That is, not tangent, suppose there is a rod like this, right, and you know it is ml squared by 12, right? The moment of inertia about perpendicular axis through the end, I don't know, if let us say it is I dash, so this length will be L by 2, so I dash is equal to known moment of inertia ml squared by 12 plus it is what, m into L by 2 whole square, or it is L squared by 4, right? So you can just calculate it as into 3, so that becomes, denominator becomes 4, sorry 12, so it is 3 plus 4, then you will get the answer as ml squared by 3. This expression is better if you can by heart, That is, if you have a rod and the axis of rotation is at its end, right? That is, this is the rod and the axis of rotation is at the end, then the moment of inertia is ml squared by 3. You can calculate it, and I think we have calculated before also. So at end, right? So similarly, this axis is at the end of this rod, so it will be ml squared by 3. But the problem is, here is the mass full? No, there is only half mass, so it is m by 2, right? L squared, is there L squared? No, it is L by 2 whole square, right? And 1 by 3 was ml squared by 3, right? And there is another guy similar to here, right? So you just have to multiply it twice, right? Clear? So you will get how much? ml squared by 2. Wow, voila, right? Clear? It's very easy if you understood the logic. Aish. 59. Moment of inertia of disk about an axis touching its diameter normal to the disk. We have done this one. That no, I don't think so. No, we didn't do now. Right. So moment of inertia of a uniform circular disk of radius r and mass m about an axis touching the disk at its diameter and normal to the disk. That is, this is the disk here, right? And you're asked what is the moment of inertia here, like this. Right, so this is the moment of inertia which you know, that is to the center, right? So this center moment of inertia is mr squared by 2 disk now. So here asked what is I dash. So this distance is r, radius, so it is mr squared by 2 plus mr squared. Very easy now. So you will get 3 by 2 mr squared. Not that tough. Okay, let's move on to the next question, guys. I don't think there is any more question in this paper. Let us take another photograph. I believe this one. No, not this one. Okay. Thank you for this sheet. Okay. 60th question. Let me see. Ratio of radius gyration of circle about tangent axis on the plane, and the circular ring of the same radius about tangential axis of the plane. That is very easy actually. So that means you are having a disk and a ring, right? And you are asked, this is the tangent, right? So this I dash 1, then this is the disk I dash 2, and this is I1, which you know, and this is I2, which you know. This is disk, na? So it is mr squared by 2 plus mr squared, right? Right? Similarly, no, this is disk, na? Right? And the tangential axis in the plane, right? So it is into, it's not into the plane, the axis is in the plane, means we are having a sheet, you have just drawn a line over it, not into that. It is not passing like this, it is passing here, right? So it is not mr squared by 2, right? In the case of disk, it is mr squared by 4, right? So mr squared by 4 plus mr squared, it is 5 by 4 mr squared. Similarly, in the case of ring, right, about from one end to another end, diameter, so it is mr squared by 2 plus mr squared, so it would be 3 by 2 mr squared, right? Now let us compare this guy and this guy with the radius of gyration. So this means that the radius of gyration is 5 by 4, and this means the radius of gyration is 3 by 2. Just find the relationship, guys. Clear? If you don't understand, I'm writing here. Let us equate this guy with mk square, k1 squared if you want. So that means k1 squared is equal to r squared 5 by 4, or k1 is equal to root 5 by 4, right? Similarly, k2 will be root 3 by 2, right? Just find the relationship. Clear? Right, let us move on with the 61 question. It's very easy. Three particles of m gram are situated at the vertices of equilateral triangle ABC. Side is L. Moment of inertia of the system about AX. AX means AX, right? AX perpendicular to AB and in the plane ABC in the, okay, whatever. Sorry, so the moment of inertia about AX is what? Moment of inertia mass into AB squared plus mass into OC squared. If you take this one as O, okay, I will draw it. Okay, I am drawing it again, guys. This is X. Let's take this point as O, right? This is point A and this is point B, and each of them is having mass. So this is 60 degree, right? So this is L, this is L, this is L. So this point is C, right? Now point moment of inertia about AX is equal to, right, m into r squared, that is this guy's moment of inertia, sorry, is its mass and the distance, right? So I will write it as ml square, this is L now, plus m into this guys will be OC squared, the distance from this axis is OC, right? So m into OC squared, so this is L, so this is 60 degree means this 30, this angle will be 30 degree, right? Then this angle will be 60 degree, so what will be this distance? It will be L cos 60, find by yourself, right? This side is L cos 60, so you can write this one as distance squared, m into distance from the axis, right? So this is axis of rotation, so C from here is m into L cos 60 whole square. This you need not find. This mass is not going to have any moment of inertia because it is along the axis. This mass is having ml squared moment of inertia. This mass is having this much distance squared into mass moment of inertia. So you will find the value as 5/4 ml squared.